Hello students, hi everyone, welcome back to our class. This is our continuation video on the topic reflection of light at curved surfaces. Right? In our previous videos we have covered so many things about the basics of light and how light reflects, how it propagates in the rectilinear manner, and also we discussed about different types of mirrors, mainly spherical mirrors. So how the spherical mirrors are made from curved surfaces. We have already discussed about the spherical mirrors like convex mirror and concave mirror. Okay, so in this video we are going to discuss about ray diagrams. What is that? Ray diagram. Yes, the ray diagrams of spherical mirrors. Ray diagrams of spherical mirrors, right? What is the meaning of ray diagrams? Ray diagrams means whenever an object is placed in front of a mirror, where the image of object is produced by the mirror, that we have to draw by using the light rays. Understand? It means every mirror produces the image of an object, and we have to represent that total phenomena by using the light rays, incident light rays and reflected light rays. That diagrams are known as ray diagrams. Understand? Yes. In your lower classes, you have already studied about how a plane mirror produces the image. Okay, let's recall that knowledge. For example, this is a plane mirror. Plane mirror will be like the flat surface. One side is coated and uncoated surface behave like the mirror. Already we discussed. For suppose an object is placed in front of the plane mirror. What happens now? How to draw the image? How we will get? Suppose let us take a point object. How to draw its image? Yes, to draw the image of any object we need at least 2 light rays from the object. Minimum 2 light rays should incident on the mirror from the object. And generally what we take a light ray from the object which incident and it reflects back, isn't it? Here, while it is incident and reflecting, it must follow the laws of reflection. What is the law of reflection? Angle of incidence is equal to angle of reflection, and the light incident ray and the reflected ray must be on either side of the normal. This is what? Normal. A normal drawn to the plane mirror. So this is one light ray, ray 1. Understand? This light ray from the object, it came and it incident on the mirror. After that, it just reflected back. Next, we need one more light ray. For that one more light ray, we take a simple light ray. We follow a method. What is that? Here, every time we are no need of measuring the angle of incident and angle of reflection. Understand? What we have to do? Instead of that, I will take a light ray along the normal itself. See, this is a normal. It is perpendicular. I am taking a light ray exactly on the normal. Then what happens? It is traveling on the normal means angle of incidence is 0, because angle of incident and angle of reflection takes with respect to the normal, isn't it? With respect to normal, the incident ray makes this much of angle, so this is the angle of incident, and with respect to the normal, the reflected ray makes this much of angle, so that is what? Angle of reflection. But here I am taking the light ray literally on the normal itself. It means it is traveling, it is passing on normal itself, and it incident on the mirror. So what is the angle of incidence? 0. Then, according to law of reflection, angle of incidence must be equal to angle of reflection. So, angle of reflection must be 0. So, how does the reflected light ray travel? Yes, it travels along the same path. Again, it travels back, isn't it? Right. So, this is called retracing the path. The light ray just travels back on the path along which it incident. So, this phenomenon is called retracing back. Yes, this is the second light ray, second reflected light ray. So we can see this is the light ray, first reflected ray, and this one is the second reflected ray. They are not meeting anywhere. You extend. them to whatever the extent you may extend, they will not meet. Why? Because the plane mirror doesn't give a real image. The light rays which are reflected, they do not meet. Then what happens? How to get the image? Yes, these light rays, the reflected light rays must be extend back of the mirror, extend them back to the mirror. So these extended rays will meet at a point. This is the image of this object, isn't it? So this is the way of drawing ray diagrams for a plane mirror. Already you have studied in your lower classes, isn't it? So we can see that the reflected light rays, they have not met because this is a plane mirror. After reflection, the light rays just diverge. They will not meet. So to get the image, what we have to do? We have to extend them back. Here real rays are not there. We are just extending them back. That's why these are just virtual rays. What are those? Virtual rays. Really light rays are not there. They are the virtual rays. So these virtual rays are meeting at a point and to form an image. So this image, due to the intersection of the virtual rays, is called a virtual image. What image this is? A virtual image. Understand? So from this what we can understand? If you stand in front of a plane mirror in your house, you will see your own image in the mirror. What type of image is that? That is a virtual image. It forms inside the mirror. Understand? The image forms inside the mirror. If you move away from the mirror, you feel that your image is also moving away from the mirror, back of the mirror, isn't it? If you move forward towards the mirror, you feel that image also moving towards the mirror. You cannot touch that virtual image. So virtual images literally form inside the mirror. They form in the mirror. Understand? They are the virtual images. The images which form in the mirror, inside the mirror, are known as virtual images. Understand? What is another type of image? Yes, the second type of image is real image. This is real image. It really exists on a plane or on a screen. Understand? In our projector classes, every school nowadays having the projector classrooms. No? In projector classrooms, what happens? There will be a white wall, white painted wall will be there. Otherwise, a white cloth will be there on the wall. There is the projector. The projector will project all the images onto the wall. Now, what are the images we are watching on the wall are the real images. Understand? There is no any mirror. There is no any lens. Lens is there. It is projecting everything onto the screen. The wall. Wall is the screen or the cloth is the screen. Now, you can easily touch that image. How I am writing the letters here? In the same way, they form on the screen. Isn't it? What type of images those? Those are the real images. They form because of the real reflected rays meet at a point. After reflection or after refraction, they will meet at a point. Here they are not meeting. To get the image, we are needed to extend them back. That's why it is a virtual image. There is no real light rays. But for the real image, the reflected light rays will meet at a point to give the real image. So if you go to cinema theater to watch a movie, you will watch a whole movie on a screen, on a very big screen. Every image of the actors and actresses will form on the screen. They are also real images. Understand? In this way, real image is formed where? On a screen. But the virtual image, it forms inside the mirror or inside the lenses. In next topic, we will discuss about the lenses. But real image, it needs a screen. Okay? So this is the topic of types of images, virtual image and real image. Understand? Yes. And this is about the how to draw the image ray diagrams for a plane mirror. But now our topic is ray diagrams of spherical mirrors. Right? How to draw the ray diagrams of a spherical mirror. Yes. In our previous topic, we have discussed some basic literature, means basic terminology of the spherical mirrors. Every spherical mirror has its own pole. So, the center point of the mirror is called a pole. See, this is the center point. It is called pole, isn't it? Now, if you draw a normal along the pole, that normal along the pole is called principal axis. Okay, and also we discussed what is the center of curvature. Okay, C, and another point is there, focus. So we have covered these things in the previous video only. Yes, this is about the concave mirror. Now, if you place an object in front of this concave mirror, let us suppose the object is a burning candle, because candle gives very bright light, no? So instead of keeping a normal object, let us keep a self-illuminating object like candle. So see, this is a candle flame. It is burning candle. So it spreads the light in all the directions, isn't it? Now this object is placed in front of the plane mirror, concave mirror. What type of mirror this is? Concave mirror. Now we have to draw its image. We have to draw the image of this burning candle by this spherical mirror, concave mirror. As we drawn an object image, point object image, like in the previous case on a plane mirror, by a plane mirror. In the similar way, we have to draw the candle's image. It is an object. Candle is nothing but it is an object. We have to draw its image by this concave mirror. How to draw? To draw this, we need at least 2 light rays, isn't it? In the previous case, we have taken 2 light rays. Here too, we need at least 2 light rays. See, this burning candle spreads the light rays in all the directions. We don't want the direct light rays which are going that side, because the mirror is this side. We need only the light rays which are coming towards the mirror. The light rays from the object should fall on the mirror. They should reflect back, and the point where the reflected light rays meet, there we get its image, isn't it? That is the phenomena. Yes, but means now here on this side, how many number of light rays are coming? Only we need that light rays, but from that light rays we needed only 2 light rays. How many light rays? Only 2 light rays are needed. So what are that light rays? If we take that light rays, they should follow the laws of reflection. What are the laws of reflection? Angle of incidence is equal to angle of reflection, and the incident ray and reflected ray must be on either side of the normal, isn't it? These are the laws of reflection. They should follow that laws of reflection. So there are certain light rays are available for us. If you take that certain light rays, we are no need of measuring angle of incidence, angle of reflection always. Automatically they follow, they obey. So they are the certain light rays. Now I am going to tell you about that light rays which are helped to draw the ray diagrams of a spherical mirror. Okay? Yes. The first light ray means light rays needed to draw ray diagrams, right? Right. The first light ray, I will draw a first light ray. Instead of taking a candle, let's take the object like, see, the first light ray in this way. First I will take for convex lens, concave mirror, understand? So this is the pole. Yes. So we can see this is the focus and center of curvature. We already discussed that the point focus is in between, exactly in the midway between pole and center of curvature. Now let's take an object. Say this is a burning candle or something else. It is an object. A, B is the object. Otherwise, let's take like this, A, B. So the object is kept on the principal axis. Now, what are the light rays needed to draw the ray diagram? Already I told you only 2 light rays are enough. So we have here 3 light rays. From that 3 light rays, we can take any 2 light rays while we are drawing the ray diagrams. I will tell you the first light ray. A light ray parallel to principal axis. It means from the object the light rays are spreading. This object spreads all the light rays, no? So I am taking now the first light ray that is coming towards the mirror, and it is parallel to principal axis. If you take this light ray, what happens? No need of measuring the angle of incidence and angle of reflection. Without measuring, you can guess how this light ray reflects, along which point it reflects. Yes, it reflects back from the mirror, from the focus. Understand? So this is the first light ray that we have to take. A light ray from the object parallel to principal axis. It incident on the mirror by traveling parallel to the principal axis. After traveling parallel to principal axis, it reflects back through the point focus. We should remember this point. This is the most important light ray. It is very easy to draw, isn't it? So I will write now a light ray, first light ray. What we are talking? Talking about light rays needed to draw the ray diagrams. A light ray parallel to principal axis. Parallel to principal axis. Okay? Yes, this is the light ray. What happens to this light ray? After reflection, it passes through focus. After reflection, it passes through focus. Right? Yes. Yes, pause the video and draw this. We have to remember the most important light ray. This is a light ray from the object which incident on the mirror by traveling parallel to principal axis. After traveling parallel to principal axis, what happened? Reflecting and passing through the focus. So this is the first reflected ray. Let us give the name as ray 1. Ray 1. Next, coming to the second one. What is the second light ray? Second light ray is converse to this, reverse. Reverse means we have to take the light ray now from the focus. It passes through the focus, it passes through the focus. What happened? After reflection, it becomes parallel to principal axis. That is the second light ray. So I will draw that. A light ray passing through focus. Right? First light ray is taken parallel to principal axis, but the second light ray is passing through focus. What happens now to this light ray? It becomes parallel to principal axis. Yes, the second light ray is like this. Pole, this is the principal axis, focus, center of curvature. We have kept the object in this way. Now I am taking the light ray from the object and that is passing through the focus. See, it is passing through the focus. Second light ray. Understand? What happens after reflection? It just becomes parallel to principal axis. This is the second light ray. Understand? Actually, these two light rays are enough. But sometimes we also use the third light ray. So, students, you just pause the video and draw these diagrams. What is that? A light ray parallel to principal axis. First light ray. After reflection, it passes through focus. What is the second one? A light ray passing through focus. After reflection, what happens? After reflection, it passes parallel to principal axis. Parallel to principal axis. Right? So, this is the second light ray. Next, let us move on to the third light ray. Right? What is the third light ray? Let us see now. Number 3. This light ray, it literally passes through center of curvature. Okay? Yes. The light ray, a light ray from object, a light ray passing through center of curvature. Center of curvature. What happens to this light ray? Tell me. Did you guess what happens to that light ray which passes through center of curvature? Yes, as its angle of incidence is 0 because see, this is the pole and this is focus and this is center of curvature. Now I am taking the object where? Here. Okay. Now I want to take a light ray from the object that is passing through center of curvature. The second light ray was passing through focus, but now this light ray is passing through center of curvature. But we know that if you draw any line from the center of curvature to mirror, that is nothing but a normal, isn't it? It means the light ray, I am taking the light ray along the normal. In the case of plane mirror, we have seen that if you take a light ray along the normal, its angle of incidence is 0. because we should measure the angle of incidence and angle of reflection with respect to normal. But this light ray is literally traveling along the normal only. It means the angle of incidence is 0. So what we have to get? Angle of reflection should be 0. So angle of incidence is 0 mean it should travel along the same normal. It should travel back along the same normal to get I is equal to 0 and R is equal to 0. Isn't it? As I is equal to 0, R became equal to 0. So see, this is the very simplest light ray. No need of taking the parallel light rays, nothing else. Okay, you can take a light ray along the center of curvature and you just retraces its path back. The light ray itself, it is the incident and also the reflected light ray. So this is the third light ray. If you take a light ray from the object which is allowed to pass through the center of curvature, what happens after reflection? It just goes back along the same path. It means it retraces the path back. So after reflection, it retraces its path back. Retraces its path back. Understand? So this is the third light ray, the most important light ray and very easiest light ray. It is very easy to draw because if you take a light ray along the center of curvature, again you can take the reflected light ray along the same center of curvature. Let us say this is the R3. Another light ray is R3. Okay? Yes, draw this diagram also. Most important diagram. And sometimes we need one more light ray. Sometimes these three light rays are not enough to draw the image. So then we have to take one more light ray. So that light ray is fourth light ray. You can take it as, but very few times we are needed to take this light ray. What is that light ray? A light ray incident at the point pole, focus, center of curvature. It means whenever the body is here like before the focus, it's not possible to take the light ray along the focus and a light ray along the center of curvature. Okay, so for example, if the light ray is in this way, it's not possible to take a light ray through the focus. It's somewhat difficult. So in that time, what we have to take? We have to measure the angle of incidence and angle of reflection. We have to take the light ray which incident at pole. Okay, here already normal is there because normal is what? Principal axis itself is the normal. Here it incident with certain angle and let it reflect back with the same angle. We have to measure the angles here, I, R. This is the fourth light ray. It means a light ray incident at pole. Okay, so after reflection it follows, after reflection it passes on its path according to law of reflection, because there is no any shortcut method like it passes, retraces its path back or becomes parallel to principal axis. We have to measure the angle of incidence and angle of reflection, but it is needed only in very few cases when the object is very nearer to the mirror. I mean, before the focus, if the object is placed, and at that time it's not possible to take all the previous light rays. Okay, we take one light ray parallel to principal axis. Okay, but we need another light ray. At that time, this light ray is helpful. Understand? Yes, here we needed to measure the angle of incidence and angle of reflection. So these are the light rays needed to draw the ray diagrams by using a concave mirror. Understand? And same thing will be happened again in the case of convex mirror. Let us see now how to take the light rays for convex mirror. These are for concave mirror. Now we will take for convex mirror. Again the same light rays. The first light ray parallel to principal axis, a light ray parallel to principal axis to PA. PA means principal axis. See, this is a convex mirror, isn't it? Convex mirror, and this is the principal axis. We know that its center of curvature is this side. Focus and center of curvature will, because its curve is this side, no? So its center of curvature is on this side. You take the first light ray. You have kept an object in front of the mirror. What is the first light ray? Parallel to principal axis. Yes, this is the light ray parallel to principal axis. Now, how does it reflect? How it should reflect now? Yes, to know that, we have to let us first draw a normal. If you draw a normal, this is the normal, because center of curvature is here. So this is the normal. So this is angle of incidence. So how does the light ray reflect? Yes, it reflects this side, because incident ray and reflected ray must be on either side of the normal. So it goes like this. Understand? So whenever the light ray is taken in this way, but it must follow, if you extend it back, it must pass through the focus. Okay. Same like the previous case. In the previous case, after reflection, because it was a convergent mirror, concave mirror was a convergent mirror. So after reflection, what happened? The reflected light ray passed through focus. But here it is not passes, because it is divergent mirror. Now already we discussed in the previous video, it is a divergent mirror. It just diverges the light ray. But whatever the light ray, reflected light ray is diverged, if it extended back, it must pass through the focus. It must pass through the focus. In such a way, the light ray should be reflected and it should be diverged. Okay? Yes. So after reflection, if the ray is extended, then it should pass through focus. Okay? Because the direct reflected ray doesn't pass through focus, but here if the reflected ray extended back, it passes through the focus. Yes, this is the first light ray. And the second, same like the previous case, but here the real light ray doesn't pass through the focus, just extended ray passes through the focus. Second is what? A light ray, it's reverse. A light ray parallel to principal axis. Parallel to PA means principal axis. What happens to this light ray? See, here this is the convex mirror. We're talking about the convex mirror, no? Here the focus and center of curvature. Here we kept an object. How to take the light ray? A light ray parallel to principal axis. From the object, a light ray incident on the mirror parallel to principal axis. What happens it? After reflection, it just diverges. Sorry, first light ray is parallel to principal axis. Next second light ray through focus. Yes, a light ray through focus. A light ray through focus, because parallel to principal axis over. Next, through focus, we have to take the light ray, and that light ray, literally it is passing through focus. But how does it come? It can come up to here only, no? So it comes up to this point only, because it cannot come. But if you extend the incident light ray, it must pass through focus. In such a way, we have to take a scale and put like this, and you just extend it. Up to here, you draw the real light ray. From there, you just extend like dotted lines. Yes, this is the light ray. What? We have taken, which is passing through focus. It appears to be passing through focus. Really, it is not passing. It appears to be passing through focus. What should happen after reflection? Yes, it should become parallel to principal axis. This is the second light ray, R2. Okay, this is the first light ray, R1, and this is the second light ray, R2. Isn't it? A light ray, what is this light ray? A light ray is taken such that it passing through the focus, appears to pass through focus. After reflection, it became parallel to principal axis, right? Yes. So after reflection, it passes parallel to principal axis. Parallel to principal axis, right? Yes, draw the diagram. Next, the third light ray. What is the third light ray? See, the third light ray is same as the previous case, a light ray through center of curvature. A light ray through center of curvature. center of curvature, right? So see, this is a convex mirror, right? So here the focus and center of curvature. Here we kept an object, okay? A, B is the object. Now we have to take a light ray such that if you extend, this is the light ray from the object, we have to take such that in the previous case, how we have taken, if you extend it back of the mirror, it should pass through focus. But here if you extend it back of the mirror, it should pass through center of curvature. Isn't it? Yes. It means what happens after reflection? Because it is passing along the center of curvature means it is passing along the normal. So angle of incidence is 0. So what should be angle of reflection? It should be equal to 0. So the light ray just retraces its path back. This is the third light ray, R3. Okay. So after reflection, it just retraces its path back. Okay, these are the most 3 important light rays, and also we needed to take the 4th light ray. It's not much important, but only one case. It's just used in the concave mirrors only. It's not much used in the convex mirror. Why? We will see in the next video. Okay, yes. So dear students, I hope you understand well about the ray diagrams. We need 3 light rays. Actually 2 light rays are enough. So we have 3 light rays with that which can be taken very easily and which we can draw them easily. So among the 3 light rays, only 2 are enough. What is the first light ray? For whatever it may be, maybe it is a convex mirror or maybe it is a concave mirror. The first light ray is a light ray parallel to principal axis. After reflection, it passes through focus. And second light ray, a light ray through focus. After reflection, it becomes parallel to principal axis. And third one is a light ray through center of curvature. After reflection, it retraces its path back and passes through the same center of curvature. So among these 3 light rays, it is just enough to take any 2 light rays to draw the ray diagrams. Already I told you what are the ray diagrams. The ray diagrams are those which gives the image by drawing the light rays, incident ray and reflected ray. Okay? Yes. This is the end of this video. Let us meet in the next video, and in that video, let us draw all the ray diagrams of the mirrors. It means what type of image is produced by the concave mirror and what type of image is produced by the convex mirror. Is it real or virtual? And always, does it produce always same type of image or different type of image? In this way, we will cover so many things in the next video. Until then, take care. Bye.